Okay, the project I'm going to talk about is a little different than the typical success story you hear, because this wasn't a huge success. It wasn't a huge project. It wasn't some giant skyscraper that saved millions of dollars. It was just a little project, actually a bunch of little projects. But it was a success, and BACnet played a key role in it. Now, to understand why you should be interested in a little project, I want to give you an example from a different field. 1929 was not a good year for the stock market. A lot of people lost a lot of money in 1929. One of those people was Groucho Marx. Years later, Groucho said, "I lost over $200,000 in the stock market crash, but I was lucky. Some people lost millions. I would have lost more, but that was all I had." Okay, clearly $200,000 is not a lot of money when you compare it to the stock market, but it was a lot of money to Groucho. It was important. Sometimes small things are important, and especially if you have a bunch of them. I want to talk about an Orlando City project. This was a stimulus project. They got $1.75 million to do the project, which is a pretty fair chunk of change, but they had to spread it across 26 buildings. So each individual building was, in effect, a small project. The buildings ranged, they had some community centers, some government offices, quite a few fire stations. Most of the buildings were under 10,000 square feet. Primarily, these were the small packaged rooftop DX systems. They had a couple chilled water systems, mostly packaged DX. Buildings ranged anywhere from 5 years to 70 years old. But when you added all these buildings together, the combined utility bill was over $500,000. So there was some potential there. It was just spread across a lot of small projects. They did an energy survey to decide how should they prioritize the money. What should they spend it on? They decided they were going to do a controls retrofit on all of these buildings. Some of the ones with the really old, the really decrepit DX systems, they do an equipment replacement, but they didn't have enough money to do a lot of equipment replacement. They did some lighting replacement on a few small projects. I'll talk a little bit more about that. And several places they installed VFDs on the fans so that they could have some variable speed. They also installed some new hot water systems, primarily in the fire departments, because people live in a fire department 24/7, so they use a lot of water there. And they used BACnet, of course, to tie everything together. When asked why they used BACnet, the first reason they came up with was it's an open protocol supported by multiple vendors. They knew it was something that would last, that they could use for time, they could add on to the project as time went on. BACnet was already a proven success story for tying multiple buildings together across a wide area, which is what they wanted to do. They also commented that the ASHRAE Standard 135, the BACnet reference, helped them specify the project. The BTL, BACnet testing labs, that was very important because they could use BTL listed products. And there was an online specifying tool that helped them write the specs. While a lot of times you hear about BACnet projects where you get multiple control system vendors together, they just wanted to pick one prime control vendor. They weren't interested in what they called a science fair project of proving that they could talk to multiple control vendors. That's already been done. Now they had multiple different pieces of equipment that they tied into the system using BACnet, but they picked one primary contractor primarily because it gave a single point of responsibility. It made managing the project easier, made it easier to make changes. As one project manager told me once, he liked a single belly button that he could push if things needed to be changed and have that person responsible for making the changes. So that single vendor was responsible for tying all these buildings and different subsystems in the buildings together into one unified front end. They also liked BACnet because it wasn't going to keep them tied to that one vendor. They picked the vendor, the government project, they went through a competition, picked a vendor that they liked, that they thought could do the project, but if they weren't happy with him, they weren't stuck with him forever because they were planning on additional follow-on work And if they weren't happy with the vendor that did the primary work, BACnet gave them the flexibility to change to a different vendor for their follow-on projects. And by the way, this is not my summary of BACnet. This is according to the Orlando city engineer who was in charge of the overall project, and also the design engineer that pulled this together. I talked to them, and these were the reasons they gave me why they chose to go BACnet with this project. Okay, let's get into a little more detail on the design. The project itself, you can see every red dot is one of the different buildings. So it's scattered over a fairly wide area, clustered in the city center, but they got refuse treatment, or I'm sorry, wastewater treatment, several fire stations, widely scattered buildings in this project. Design details, they decided based on the energy survey to concentrate on the low-hanging fruit. And that primarily was installing new DDC controls on all the heating and air conditioning. Some of the buildings were old enough they had standalone thermostats. Some of them had an older DDC system in it, but it was all standalone for each individual building. It wasn't tied together, and the system, frankly, had not been maintained very well over the years. One of the things they liked about the new system was they wanted to do all the scheduling through the front end. Because remember, these are multiple small buildings. They didn't have an energy engineer in each building. They really didn't even have somebody responsible for the building systems in each building. There were people who worked there. On some of them were intermittently occupied. Community centers, people were only there sometimes. Now, the older DDC system did have scheduling capability, but they didn't have people in the buildings who were very good at scheduling, using the schedule. And if you've ever been in the situation of having people complain to you because they came in when you didn't expect and the system wasn't running, you probably know what the solution is. Okay, we'll make the schedule go for a long time, some of them 24 hours a day, and that way nobody ever complains. Not very good for energy, but nobody complains. So with the new system, they were able to handle the scheduling from a central office. They installed demand-controlled ventilation in a lot of the buildings where they would control the outside air dampers based on the CO2 readings. And of course, Orlando has a lot of hot, humid weather, so there are times when bringing in too much outside air really costs you. So this let them fine-tune that, bringing in enough air to keep the buildings comfortable, the people healthy, but not too much. They also used occupancy sensors in some of the intermittently occupied rooms. Some of the entire building was intermittently occupied, but even in the buildings that had people working there every day, they weren't using every room all the time. So this let them shut down systems that weren't being used. They also monitored comfort throughout the building. And that's very important because after all, the whole reason for the HVAC system, the reason for the building to begin with, was to provide a comfortable, healthy place for people to work. And if they were saving energy at the cost of making people uncomfortable, it wasn't a success. So they were monitoring temperatures, they were monitoring CO2 levels, they monitored humidity, kind of wrapped it all together in an index 0 to 100 to indicate the comfort, because they wanted to make certain that as they went in and made changes, as they used the demand-controlled ventilation to cut down on outside air, things like that, that they weren't making people uncomfortable. Overall, these 26 buildings had 82 air handler units, mostly small rooftop units, 5 to 15 ton. 3 of the buildings did have small package chillers and chilled water systems. 76 of these air handlers were aging VVT systems, the variable volume and temperature. Essentially, they were using a bypass to control the volume of air being pumped. So the fan's running at a constant speed, and if you don't need air in the zone, it gets circled back around. That saves some energy, but not as much as actually slowing down the fan. So that's where they put in the VFDs, to slow down the fan. Also, the system had been running on fixed supply air temperature for the air handling units. They started monitoring the actual demand for cooling and modulating the temperature as well as the flow to save energy. 43 units were so far gone they replaced them with new units. And on those they were looking for high efficiency units, a seasonal effectiveness rating of about 16. They put in remote monitoring on all of the buildings, and also all the buildings were metered. Some of them were sub-metering. They tied that together as well so they could follow the metering. And they installed current sensors at some key points just so they could verify the equipment was or was not running. A few buildings had, particularly the buildings with some vehicle maintenance, had some high bay, low pressure sodium lighting. They replaced that with LEDs. And the fire station, they installed heat pumps to provide cooling, and then the rejected heat from the heat pump they used to heat the domestic water. Overall, the results, first year they had about a 23% reduction in the kilowatt hours. The green is the total metered energy into the building, and the blue is the net energy. Their baseline year, obviously it was the same. They cut over $100,000 in the metered cost the first year after they put in the system. They also qualified for about $40,000 in rebates. So in total, they saved $164,000 the first year this was in an operation. Looking at one building as an example, Primrose Plaza was a 43,000 square foot multi-use office facility, one of the largest buildings in this project. The police station, police offices were in there along with other government offices, designed for about 50 people. They had packaged air control units. They actually had a packaged chilled water plant in there as well. The retrofit work they did at this project was strictly a controls interface. Now they used BACnet to interface to the existing chillers so they could bring it in. They had sub-meters on the north and south wing as well as on the chiller plant. They brought those all together with BACnet. They did not do equipment replacement though. This was just a control system retrofit. This is a floor plan of the building. The color is an indication of the temperature. Green means it's between the heating and cooling set points, kind of minimum energy use and comfortable for the people. Yellow indicates they're in a low cooling mode, meaning they're at or maybe slightly above the cooling set point. Still not necessarily uncomfortable for the people, but they're actively providing cooling. They're providing more than the minimum amount of air to those zones, more than the minimum amount of cooling. This graph shows what the building looked like when it's fully occupied. Before they did the retrofit, this was the way the building looked all the time. After the retrofit, this is just a snapshot at one point in time. All of those gray zones, those are rooms that are now unoccupied. So they were able to shut down the heating and ventilation, or the air conditioning and ventilation to those rooms and save energy. They had occupancy sensors so that when people were using those rooms, they would provide the air conditioning, but significant savings just from cutting back on that. We'll look at one room in particular here. This is just the equipment schematic. The way it's working, as you can see right now, it's occupied, the fan's running, providing DX chilling. Supply air temperature is 48.2. That's a little bit cool. And the room is 69 degrees, which is also normally on the cool side. Probably can't read that. This is the SWAT briefing room. I've never been on a SWAT team or in a SWAT briefing, but my guess is that it's kind of a tense situation. And not only that, the guys are fully geared up in uniform. I don't know if they're wearing bulletproof vests in the briefing or not, but it's probably a point where they want cooling. And again, the purpose of this was to keep people comfortable. They weren't trying to cut back on energy at the expense of comfort. So if this was the temperature that the SWAT team was comfortable at, they wanted to maintain that temperature. They just wanted to do it for the minimum amount of energy possible. So you see up there, there's an occupancy sensor. It's currently on. This is the same room. I took a snapshot at a different point in time. Now it's off. Fan's off, DX cooling is off. Temperature's risen up to 76 degrees. So it's a little warmer in there, but that doesn't really matter because there's nobody in the room. So just by shutting down the system when it's unoccupied, they can save a significant amount of energy. And then with the CO2 sensor and everything, they can make certain that it stays comfortable when people are in there. This is a graph showing monthly energy use. The line at the top, that's the average monthly use for the previous 12 months. They didn't have month-by-month figures, so I just took the average. This is before the retrofit. That was the average monthly use. After the retrofit, this is actually 11 months of data because they installed it in September. It's a new project. So averaged it out over, extended it for 12 months. This is the average energy use after that. So you can see a significant savings there in Primrose Plaza. The green is the energy used by the chiller. The orange is the total metered energy then of the other systems in the north and south wings combined. And it varies a little bit month to month, but as you can see, the average is 34% reduction in kilowatt hours. And they were also able to cut back on demand. They did some demand limiting through the controls, and that gave them a 39% reduction in cost because they avoided some demand charges. I know you can't read the numbers here from the back of the room, but that's the environmental index, the combined index showing them how comfortable it was on a 100-point scale. It's 97, 92, 91. It averaged in the low to mid 90s on a 100% scale. So that was important to them. They're significantly saving energy, but they're also keeping the building comfortable. Some other results, feedback from the building occupants were very positive. They felt they had better control over the environment. Several feedback comments that was more comfortable after they did the retrofit projects. And the people who were supposed to be running the buildings previously had no tools to do it. Now they could at least see the building. Now they could see what was going on, and they could also call in and report problems. The maintenance folks were really happy with this because now they could see the buildings remotely. They could do troubleshooting. Sometimes they could fix a problem remotely. If they couldn't fix it remotely, at least they had a good idea what the problem was. So when they dispatched a maintenance team out there, they knew what type of tools, what type of parts they needed to take with them. Interesting aspect of this, the $1.75 million they got in stimulus money, that was a grant. So the city set this up as a revolving fund. They used that to fund these first 26 buildings. And then by monitoring the meters, documenting what the savings were, they put that money into a revolving fund that they could use in the future to implement even more energy programs. Okay, no project goes completely trouble-free. There were a few problems along the line, and there were a few lessons learned from that. They discovered the most successful single thing they did were controls retrofit. And in the controls retrofit, not surprisingly, one of the most effective things is to turn off the HVAC when there's nobody in there. It's hard to be more efficient than off. So that's a very effective way to cut back on energy. In some buildings, that amounted to over a 50% savings just in itself, just by using the occupancy sensors to turn things on and off. As I said, the previous system did have scheduling capability, but it was so cumbersome to use that in many cases it wasn't used, or the schedules were so generous that there were lots of times when the system was running, but there was nobody in the building. They found that community centers had the most significant savings, not surprisingly, because there the whole building was intermittently occupied. And this gave them the flexibility. If they knew there was going to be occupied, they could start it up in advance so it was comfortable when the people got there, but they didn't have to keep it running when the people weren't in the building. Fire departments were a challenge because fire departments are operating 24/7. So they could not shut systems off in the fire department. Furthermore, the firefighters tend to like things cool, especially in the sleeping quarters. And I know from personal experience, because I had a house fire one time, and I sure was hoping that those firemen were well rested when they showed up at my house. So Again, they weren't trying to be thermostat police and dictate what the set points had to be. They let the firemen set the set points where they were comfortable, and then they adjusted the system to keep as efficient as possible and still maintain those conditions. One of the things they found out was that the equipment replacement projects had a fairly poor return on investment. It was okay, but typically it was 7 years or more for the return on investment, simply because of the cost of replacing the equipment. If they could just do a controls retrofit, they had a much shorter return on investment than for an equipment replacement. But as the energy engineer for the city pointed out to me, ROI really isn't a very good tool to use to justify a project if the equipment needs to be replaced anyway. And the equipment they were replacing was worn out. His suggestion was a better way to measure ROI in that case is not how much do you save by replacing the equipment versus doing nothing at all, because doing nothing at all isn't an option. It's how much would it cost you to replace it with a standard piece of equipment, say an efficiency rating of about 13, versus spending the extra money for a high-tech, higher efficiency piece of equipment, excuse me, and seeing what additional savings you have from that.
Steve, in that situation, did they try to project what their emergency maintenance costs might have been if they had tried to keep that old equipment running?
Not that I know of. They didn't have any figures on that. Like I say, the maintenance crews really liked the new system, but they didn't say anything in terms of particular savings in service calls. They also discovered that the existing equipment that they were replacing in many cases had been oversized to begin with. Now, they didn't discover this right away though, because over the years the performance of that equipment had deteriorated to the point where it was more or less right-sized. So they were going into a building and the existing equipment was old and worn out but still doing the job, so when they replaced it with the same size equipment. And they found out that when they did that, the new equipment now was oversized. And they started having problems with short cycling. They started having some humidity problems. Eventually, they were able to work that out with control. But it would have been much better if they had gone through and done a load survey on the building first and put in the right-sized equipment to begin with. Just replacing with the same nameplate capacity as what was in there originally proved not to be a good idea. Probably the most important lessons they learned were number one, don't ignore small buildings, especially if you've got a bunch of them. You can get significant savings by going through and doing just simple retrofits to small buildings. And of course, BACnet worked as advertised. They were very pleased with the way BACnet let them tie everything together, and the city engineer has declared that all future energy projects are going to be BACnet. That's a quick overview of the Orlando City project. Any questions?